Hi there. Let's start with assertion and reason. Assertion: divergent plate margin cause seafloor spreading. Reason: construction plate margins result in the formation of faults. Assertion is correct, reason is also true, and reason is the correct explanation of assertion. Now, understand how divergent plate margin cause seafloor spreading. This is the mid-oceanic ridge. Here volcanic eruption happen, and from this the plate is diverging. From this mid-oceanic ridge it is moving in right direction, and here it is moving in left direction, and that is called divergent of the plate. Or once the volcanic eruption happen, it cools down and it made a plate, that is it construct plate. So divergent plate margin cause seafloor spreading, and it happens due to faults. Okay, now moving to the one more information here. As we move from the mid-oceanic ridge, we will get older material. As we move from the mid-oceanic ridge, we will get older material, and near mid-oceanic ridge the newer material will be found, because it is divergent, means moving from mid-oceanic ridge to in this left direction, and from here it is moving in right direction. So the newer material comes from the mantle in the form of volcanic eruption in the ocean. They get cooled down and they move away on the next instance. So the newer material will be near mid-oceanic ridge, and older material will be on away from the mid-oceanic ridge in both the direction. Now moving to the next question. The term Swash refers to, there are four options and the correct option is B. What is Swash? Forward movement of seawater up the beach after the breaking of a wave. Now look at this image. It is on the beach side. The ocean water comes and moving in the up direction, in the forward direction after the break from the wave. That is called swash. And what is backwash? As they return back. After swash, they return back to the ocean. That is backwash. So hope it is clear from this two diagram, and we can also get this diagram. Forward direction is swash and backward directions means returning to the ocean is backwash. Moving to the next question. The drainage pattern which is not controlled by parent structure on which it flows is termed as, there are four options. It is insequent. We have already discussed about insequent. Now in question it has been asked that is not controlled, that is not determinable by the parent structure, means they are not determined by their slope or the structure of the area, how drainage pattern develop there, that is insequent. And resequent, subsequent, consequent, as we have been discussed here in this diagram in the previous lectures. Let me explain insequent here. The river valleys whose courses are controlled by factors which are not determinable are termed as insequent. And we have already discussed the terms similar to insequent, that is resequent, subsequent, obsequent, consequent. The main river that is moving in the slope of the direction, from top slope to the bottom slope, that is consequent. And resequent is, and subsequent is subpart, that is merges with the consequent at right angle, that is subsequent. And resequent, the river moving in the direction of main river, that is consequent, and meet at the right angle to the subsequent, that is resequent. And obsequent is just opposite to resequent, means the direction of the obsequent river is opposite to the main river, that is consequent. So the obsequent meet at 90 degree with subsequent at right angle and in the opposite direction of consequent is called obsequent. And what is insequent? Which is not determined by the feature of the slope or the area or geographical features, that is insequent. So the question was drainage pattern which is not controlled by parent structure on which it flows is termed as insequent. Now we will get clear about insequent in next question also. Let's see next question. A drainage pattern which is not related to a structure of the region is known as, there are four options. This is the correct answer. Superimposed drainage is a drainage pattern which is not related to the structure of the region. Means superimposed drainage is a insequent drainage, means they are not related to the structure of the area. Means superimposed drainage is insequent. And trellis, dendritic, radial drainage is related with the structure of the area and how there are slopes or mountains. They are related with the geographical features of the area or a structure of the area, or with the parent rock of the area. They are related with parent structure of the area, that is trellis drainage, dendritic drainage, radial drainage. But superimposed is not related with the structure of the region or geographical feature, that is insequent. So it is super drainage pattern which is not related to the structure of the region is known as superimposed drainage. Okay, now we can also get some insight from here. Some river system is not related to a structure of the region it drains, and this is because it is originally developed on a surface on which it is now located. Let's see. Like antecedent streams, superimposed streams are also not adjusted to the regional geographical structure and slope, and thus are insequent or anti-consequent stream. Now we have to understand consequent is are determined on the feature of the slope, that is consequent, but anti-consequent is insignificant. Insequent, that is anti-consequent stream. So antecedent stream and superimposed streams are insequent, or we can also say anti-consequent streams. Now understand the important terms from this diagram. What is superimposed? That is also called epigenetic or superinduced drainage. See, this is the first diagram. There was no stream flowing. Over a period of time, there will be some depositional feature. There will be deposition, and once there will reach deposition, after a period of time, there may be a stream moving from the area, and now river have started moving in the area, and now this part that is coming out, that is cut by the river, and river as moving in the second image or diagram is same in the third diagram, means they have not changed, the river has not changed its path or slope, but whatever comes out it has eroded. And as here we can see in image diagram 3, the river is moving in the same fashion as it was moving in the second. So it is superimposed, means the river is moving here is same. So superimposed epigenetic or superinduced drainage we can understand from this diagram, or their examples are Damodar river, Subarnarekha and Chambal river. Even Son river is also example of superimposed. Now moving to the second important term, antecedent river or inconsequent drainage, means insequent river. Antecedent river is how antecedent is different from superimposed, although both are insequent. Superimposed and antecedent, the only difference is in the first diagram there was a river like Ganga, and once there is a fault or some geological tectonic disturbed there in the area, the river start cutting down, and the river has also changed its some paths or eroded beneath the coming out of mountains in their path. So that is antecedent. What is difference between antecedent or inconsequent with superimposed? In superimposed, in the first diagram there was no river, but after a period of time there is some depositional features happen and river start flowing. And when river start flowing, once there is some materials comes out from beneath, the river started cutting and it maintains its path as in the second diagram. So that is superimposed. But in antecedent, river was already there, means whether depositional feature happened or not, but river was flowing from the first instance. And the second diagram, once there is some geological imbalances happen in the area, like so you can understand Himalayas coming out, the river started cutting down and even it has changed some paths. So that is antecedent or inconsequent drainage. Examples are Ganga, Satluj, Indus are antecedent river or inconsequent drainage. Hope you understand difference between superimposed and antecedent river. Both are insequent, but there is some little difference we have understand from the both diagrams. Now moving to the diagram for understanding of drainage pattern, which are given in the options, others important terms like dendritic pattern. You can see this pattern. This is the most common drainage pattern in the world. General, we can see these drainage patterns look like branches. There are some branches, even it look like nerve system. That is called dendritic pattern. But here we can see there is a volcano mountain. Due to volcanic eruption, a mountain has been created and waters has started moving on the slope in the from the center to the downward. They are moving. Okay, that is the image of drainage from the top. It looks like this way. That is moving in this way and this way and this way and this way, this and this. That is radial pattern. That is also a drainage pattern, that is radial pattern. Here we can see due to fault, there are faults in mountains, and the gap that is due to fault, water start flowing. That is in the form of a rectangular. It seems like rectangular. we can relate this drainage system, that is rectangular pattern. And this is trellis pattern. This is created due to folds. This was created due to faults, and this drainage pattern due to folds. We can see here, this is a folded mountain, this is also. So, from the heights, due to slope, the river start moving from here, here, from up top to down, and on the other folds top to down, and meet and in moving in this direction and in this way, that we can relate from this. That is a trellis. The only difference between rectangular drainage pattern and trellis drainage pattern is it is widely spaced. Its tributaries are widely spaced, but here they are not widely spaced, and it happens due to faults, and this happened due to folds, and this is due to volcanic, the mountains created by volcano, or even due to mountains. It moves from the center to the outwards. That is radial pattern, and dendritic is the most common pattern, looks like branches. Another diagram we can understand for clear understanding. Dendritic pattern, we can see this is a from the top to down it is moving, this is coming, their tributary joins, that is dendritic pattern. And radials, we can relate this radial, and trellis looks like this, they merges, and rectangular due to fault, and this is a parallel. Hope you understand the important terms related to drainage patterns: dendritic, rectangular, radial, trellis, and antecedent rivers. Rivers was already flowing in the first instance, and whatever comes out, they have eroded, and they flow their path. Superimposed, in the first instance there was no river, but once there are some depositional feature, river start moving, and whatever comes in their way they have cutted, that is superimposed. So our question was, the drainage pattern which is not related to a structure of the region is known as superimposed drainage, because trellis, dendritic and radial are related to the structure of the region. Here we can understand dendritic, radial, trellis. They are related with the structures of the area. That's why they are following like this. But on the other hand, superimpose is not related to the structure of the area. We can get here. We can understand it from the here. Not related with the geological features of the area. That is superimposed. So hope you understand this. Moving to the next question, that is the last question of the day. Normal cycle of erosion is associated with, there are 4 options. The correct option is fluvial erosion. And Davis cycle of erosion is also known as normal cycle of erosion. For stream erosion and landscape development, his stages in the fluvial cycle of erosion published in 1909 or 1909 defined as young, mature and old sequence. In the development of river valleys and the landscape, the rivers were eroding. That is, in the old age, what we get? Penny plain, that is given by Davis, that is related to fluvial erosion. So normal cycle of erosion is another name of Davis cycle of erosion. We can recollect our understanding from this diagram. Davis cycle of erosion, this is youth stage, and this is mature stage, and this is old stage, and the low relief form in the later stage and the last stage, that is called penny plain. But that's the term has been given by different geographers with different terms. Like in drum have the low features developed, due to cycle of erosion in rough has been given by Peng. Pediplane has been given by L.C. King. Hope you enjoy this lecture. Thank you so much. Take care. Bye bye.